স্টুডেন্টরাই কিন্তু করতেছে। আমি নিজে বুয়েট থেকে, এবং আমার যে পিএইচডি স্টুডেন্ট ওরাও বুয়েট থেকে, এবং তাদের সবারই ব্যাকগ্রাউন্ড সিভিল ইঞ্জিনিয়ারিং এ, বাট তারা এখন কম্পিউটার সায়েন্সের প্রজেক্টে কাজ করতেছে। তো আমি জাস্ট সবাইকে একটু দেখাইতে চাই যে কি ধরনের কাজ। তো কিছু প্রজেক্ট আছে যেগুলো আসলে একটু কনফিডেন্সিয়াল, কিছু আছে যারা মিলিটারি প্রজেক্টের কাজ, তো লাস্টের দিকে কিছু স্লাইড, তো ওই সময় যদি ইয়ে করা যায়, স্টপ করা যায়, তাহলে ভালো।
আমরা তাহলে রেকর্ড না করে রেকর্ড স্কিপ করতে পারি, কোন মানে এটা মানে ম্যান্ডেটরি না আর কি, মানে সমস্যা নেই, রেকর্ড স্কিপ করলে কোনো প্রবলেম নেই আসলে।
আচ্ছা, আর এই স্লাইড গুলো কি দরকার, মানে ক্লাসে স্টুডেন্টদের কোনো এক্সাম বা কিছুর জন্য লাগবে? তাহলে আমি ওগুলো বাদ দিয়ে দিতে পারবো।
হ্যাঁ, তাহলে এটা দিয়ে দিলে সুবিধা হয় আর কি। হ্যাঁ, তাহলে একটু
আচ্ছা,
স্লাইড গুলো যদি হচ্ছে যে ওই স্পেশাল স্লাইড গুলো যদি বাদ দিয়ে তাও বাকিগুলো যদি একটু দিয়ে দিতেন, তাহলে আমি স্টুডেন্টদের সাথে শেয়ার করে দিতে পারতাম আসলে। আর আলটিমেটলি হচ্ছে যে টার্ম ফাইনাল পরীক্ষায় এখান থেকে কোয়েশ্চেন থাকবে আসলে, আপনি আজকে যে সম্পর্কে বলবেন
আচ্ছা,
এখান
আচ্ছা,
থেকে
আচ্ছা,
কোয়েশ্চেন
আচ্ছা,
রাখবো আসলে।
তাহলে আমি জাস্ট দেন ইউ গাইস ক্যান অ্যাকচুয়ালি রেকর্ড, আই ক্যান জাস্ট মুভ দিস থিংস, এন্ড অ্যাজ লং অ্যাজ এটা কোনো মানে ইউটিউব চ্যানেল বা কোথাও পাবলিশ করা হচ্ছে না, দেন প্রজেক্ট গুলো হচ্ছে গিয়ে সেফ আর কি। আমি
না না,
এগুলো
ঠিক আছে,
লাস্টে
এটা ডেফিনেটলি, এটা আমি গ্যারান্টি দিতে পারি যে এটা অন্য কোথাও পাবলিশ করা হবে না, শুধুমাত্র টিমসেই থাকবে আর কি।
শুধুমাত্র, হ্যাঁ, টিমসে যে ডাউনলোড করা যায় না যে অপশনটা, রাইট? ওকে,
হুম।
আচ্ছা, আম, আমি জাস্ট স্লাইডটা শেয়ার করার চেষ্টা করি। হ্যালো?
হুম।
হ্যাঁ, হ্যাঁ, রাইট, 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 যে প্রজেক্ট গুলো, যে ওইটা আমি বলতেছিলাম যে রেকর্ড অফ করার পরে আমি না হয় রিসেন্ট যে প্রজেক্ট গুলো কাজ চলতেছে, প্রজেক্ট গুলো স্টুডেন্টরা,
হুম।
বুয়েটের স্টুডেন্টরা কাজ করতেছে, হুইচ ইজ মোর এক্সাইটিং, রাইট? সিভিলের ছেলেপেলেরা, তো
জি
আমি আমি ওগুলো না হয় ইয়ের পরে দেখালাম আর কি, রেকর্ডিং বন্ধ করার পরে।
জি, তাহলে এটাই করি, তাহলে ক্লাসের শুরু থেকে রেকর্ডিংটা অন করে দিই। তখন হচ্ছে
হুম,
যে
হুম,
আপনি জাস্ট আমাদেরকে জানান যে হচ্ছে যে যখন ওই স্পেশাল স্লাইড গুলোতে যাবেন তখন হচ্ছে রেকর্ডিংটা অফ করে দেবো আর কি।
রাইট, রাইট, রাইট,
জাস্ট একটু
ওকে,
জানালে আমি তখন অফ করে দিতে পারবো।
সাউন্ডস গুড। আমি সরি, আমি এক্সট্রা টাইম নিচ্ছি, কিছু মনে করো না।
না না, কোনো
তুমি করে
সমস্যা, কোনো
বললাম
সমস্যা। ইন দ্য
সবাইকে,
মিনটাইম হচ্ছে
আই
যে আমি
গেস কেউ নিশ্চয়ই আমাদের সিনিয়র না এখানে, তাই না?
না না না, কেউ সিনিয়র নেই, সবই হচ্ছে
কোন ব্যাচে?
আমাদের
22
এরা
ব্যাচ?
সবাই হচ্ছে 22 ব্যাচ আর কি,
ওয়াও।
এইচএসসি 22, অনেক জুনিয়র আসলে।
ও,
হ্যাঁ। আমি আমি একটু ইন দ্য মিন টাইম হচ্ছে যে ডক্টর সাকিব সম্পর্কে একটু আলোচনা করে রাখি আর কি। সো ডক্টর সাকিব হচ্ছে যে ইউনিভার্সিটি অফ টেক্সাস আর্লিংটনের আমাদের সিভিল ইঞ্জিনিয়ারিং ডিপার্টমেন্টে অ্যাসিস্ট্যান্ট প্রফেসর, এবং উনি সিএসসি ডিপার্টমেন্টের হচ্ছে যে অ্যাসিস্ট্যান্ট প্রফেসর হিসেবে কাজ করতেছেন আর কি, কম্বাইন্ড। সো উনি টেনিউর ট্র্যাক অ্যাসিস্ট্যান্ট প্রফেসর হিসেবে জয়েন করছেন, এবং এর আগে উনি পিএইচডি কমপ্লিট করেছিলেন টেক্সাস এএনএম ইউনিভার্সিটি থেকে। আর ওনার স্পেশালাইজেশন হচ্ছে যে বেসিক্যালি এআই, মেশিন লার্নিং, বিল্ডিং ইনফরমেশন মডেলিং, সো অথবা রোবোটিক্স, এই এই জিনিসগুলো নিয়ে। আর ডেফিনেটলি হচ্ছে ড্রোন এবং লাইডার, ঠিক আছে। এবং ওনার সাথে আমার পরিচয় হচ্ছে যে আমি ইউটিএ গ্র্যাজুয়েট, সো উনি যখন জয়েন করেন তখন আমিও ইউটিএতে ছিলাম আর কি। আমি ছিলাম নন টেনিউর ট্র্যাকে অ্যাসিস্ট্যান্ট প্রফেসর ইনস্ট্রাকশন হিসেবে, আর উনি টেনিউর ট্র্যাকে হচ্ছে যে অ্যাসিস্ট্যান্ট প্রফেসর হিসেবে জয়েন করেন। তো তখন থেকে আর কি ওনার সাথে বেশ ভালো সম্পর্ক। উনি আমার 2 বছরের সিনিয়র আর কি, জিরো তিন বছরের সিনিয়র, 06, তাই না ভাইয়া? হ্যাঁ হ্যাঁ, 06। তো এই তো তখন থেকে আর কি ওনার সাথে পরিচয়, এবং ওনার যতগুলা প্রজেক্ট ছিল এবং সবই অনেক ইন্টারেস্টিং, এবং উনি হচ্ছে যে কাটিং এজ টেকনোলজি নিয়ে কাজ করেন, যেটা হচ্ছে যে ওয়ার্ল্ডে বলা যায় যে খুবই রিসেন্ট, এবং এই কাজগুলো আগে খুব খুব একটা বেশি হয় নাই। সো মোটামুটি এই আর কি। তাহলে ডক্টর সাকিব, আপনি তাহলে শুরু করতে পারেন
থ্যাংক ইউ,
আসলে।
থ্যাংক ইউ, থ্যাংক ইউ, ডক্টর ইসলাম। সো যে জিনিস, আমি ডক্টর ইসলামকে আসলে আজিজ বলি যেহেতু আমার জুনিয়র। তো he was actually one of the best faculty we had here. We really missed him, and খুব রেয়ারলি আমি দেখছি যে ফ্যাকাল্টিরা যারা বইটা ব্যাক করে, এরকম যারা খুবই কোয়ালিফাইড এখানে, and I guess everyone knows that, right? He used to get like 5 times more salary here, 5, 6, even more, I guess. But leaving that to actually serve his own country and his institute is something really appreciable, right? খুব কম মানুষই করতে পারে, আমরা করতে পারিনি। তো আজিজকে অলওয়েজ অলওয়েজ কুডোস টু দ্যাট। ওদের জন্যই আমরা বুয়েটে যারা পড়াশোনা করছি এবং করতেছি তারা ভালো শিক্ষা পাচ্ছি, যারা ব্যাক করতেছে যেসব ফ্যাকাল্টি আমাদের, তাই না? তো থ্যাংক ইউ আজিজ, আমরা এখানে তোমাকে খুবই মিস করি। এবং মাঝখানে স্টুডেন্টদের সাথে কথা হচ্ছিল জিও টেকনিক্যালের, তুমি যেগুলো
হুম,
টপিক পড়াইতা ওগুলো এখানে পড়ানোর মতো খুবই লোক কম এখন। তো
আচ্ছা,
এটা আসলে বইটার জন্য ভালো, হুইচ ইজ আমি হ্যাপি অ্যাবাউট দ্যাট।
হুম,
আর আমি যেটা বলবো যে প্রেজেন্টেশন, আমাদের প্রেজেন্টেশনটা যেটা এখানে আমি আজকে যে প্রেজেন্টেশনটা দিব,
হুম,
আমি সাধারণত খুব একটা ফর্মাল প্রেজেন্টেশন পছন্দ করি না। সো ইট উইল বি ভেরি ইনফর্মাল।
হুম,
I'll just discuss
right,
about the projects that I do. And
হুম,
আমি করি বলতে মেইনলি আমার স্টুডেন্টরা, ওরাই আসলে সব করে, আমি জাস্ট গাইড করি। তো কারো যদি কোনো কোশ্চেন থাকে at any point you can raise your hand, I can stop the presentation and we can discuss about it, I don't mind. And খুব বেশি ফর্মালিটিস দরকার নাই। uh, it's we are here to learn, right? তো মানে ফর্মালিটিস এর চেয়ে কারো কোনো কোশ্চেন থাকলে সরাসরি জিজ্ঞেস করবে, I don't mind. I'll start sharing my slide. Let me um
হুম, আমি আমি তাহলে ইন দ্য মিনটাইম রেকর্ডিংটা স্টার্ট করি আর কি।
sure.
আচ্ছা, ঠিক আছে।
Okay.
হ্যাঁ, রেকর্ডিংটা স্টার্ট হয়ে
I
গেছে।
think সবাই প্রেজেন্টেশন মোড দেখতে পাচ্ছে, রাইট?
জি, 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 হ্যাঁ, প্রেজেন্টেশন বোর্ডটা দেখতে পাচ্ছি, ইয়েটা দেখতে
Okay,
পাচ্ছি না আর কি।
right. Let me change it. So, is it better now?
ইয়েস।
আচ্ছা, যদিও প্রেজেন্টেশনের সময় আমি আসলে কাউকে দেখতে পাচ্ছি না, আহ, মানে স্টুডেন্টদের রিয়াকশন বা কোনো কিছু আমি দেখতে পাচ্ছি না। So Aziz, you have to actually help me out if someone asks any questions or anything.
জি, জি, অবশ্যই, যে কেউ কোশ্চেন করলে আমি অবশ্যই আপনাকে থামাই, তারপর
আচ্ছা,
ওকে ফ্লোরটা দিয়ে দেবো আর কি।
হুম, থ্যাংক ইউ। আর যদিও আম, আমি বাংলায় কথা বলতেই পছন্দ করি এবং সবকিছু, বাট যে জিনিসগুলো আজকে আমরা প্রেজেন্ট করবো এগুলো হাইলি টেকনিক্যাল, সো অনেক বেশি
হুম,
টেকনিক্যাল টার্ম। তো আমি যদি বাংলায় কথা
হুম,
বলতে যাই দেখা যাবে পুরোটা বাংলিশ হয়ে যাবে, আম, জিনিসটা উল্টাপাল্টা হয়ে যাবে। তো তার চেয়ে বেটার হচ্ছে আমি প্রেজেন্টেশনটা পুরোটা ইংলিশে দেই। অ্যান্ড
হ্যাঁ,
I'll also start subtitle if it helps. Okay. Are you ready, Aziz? Are you recording?
ইয়েস, ইয়েস, দ্য রেকর্ডিং হ্যাজ বিন স্টার্টেড, ইয়া।
Okay. Hi, everyone. So, welcome to this presentation, and thank you, Dr. Islam, for inviting me here for this presentation. And as I can remember, I think you guys are, this is your 1-1 or 1-2, something like that, right? This is your second semester or first semester doing the surveying in the Buet field or something like that, right? So, um, I one thing I really know that if you are here, that means you have the passion to go for higher studies or understand or really passionate about civil engineering and actually want to learn. So I'll treat you that way. I'll treat you like a adult and like a mature student or researcher or whatever you think about yourself. And I'll discuss about a lot of important and high tech technologies with you guys. So again, as I'm saying, this is a discussion. It's not I'm just presenting and you'll be listening and just go home and sleep on top of that. No. If you have any question, if you don't understand anything, please feel free to ask me question. And Dr. Islam will moderate the whole session, so don't worry about it. So just to talk about myself, as you can see, this is about the CE 103 surveying. Although the topic was about drone and LiDAR for surveying, but I thought about describing a little bit more about other emerging technologies in civil engineering that I and my lab is personally using. So as Dr. Aziz also said, I'm an assistant professor in civil engineering and also in computer science and engineering. And I'm also the director of Intelligent System and Emerging Technologies Lab, which is my research lab at UTA. Um, so just to give you a brief idea about what I did before. So I started here in August 23. Luckily, I was able to. I got the chance to work with Dr. Aziz for about a year, and which was really amazing. Before that, I was an instructional faculty in Texas A&M. I was a graduate assistant there during my whole graduate studies, which was a long time, almost 4 or 5 years. But before joining here, I was an entrepreneur back in Bangladesh. We had this amazing EcoStructure private limited company. We used to work on different consulting project for different government agencies. And also along with that, we also had another startup. We call it TryFX. Um, and I think we still have that company page or YouTube page or something. It was a animation farm. So we used to develop. You guys know about this flyovers, right? That you have flyover, then Dhaka Chittagong Expressway. So all the animation 3D modeling that you can see for this big projects, we made those 3D animations. Um, just to give you a basic idea about my background, I did my civil undergrad in civil engineering from BUET, which is amazing, one of the best university in the whole world, and we're all very proud about that. Then, when I came here in US, I realized, okay, I was in design, mainly structural design and geotechnical design when I was in undergrad, and I was doing that during my industry experience or entrepreneurship experience. But then after coming here in Texas, I realized, okay, construction have more money in it, right? It sounds more money also in Bangladesh, I remember. So I started my master's in construction management, but eventually I realized, okay, this is not it. I have more interest in AI, data science, and other sector like emerging technologies. So I did my PhD in interdisciplinary engineering. Um, my degree is actually called interdisciplinary engineering, and it was actually a combination of three different departments. So I took most of my courses from computer science, electrical engineering, and psychology to understand human factor. Um, so I'm also the director of Intelligence System and Emerging Technologies Lab, which is at UTA. It is my research lab, and it started from UTA. And we mean generally the theme of this lab that we have is to explore the emerging and intelligent system, mostly towards a more sustainable and resilient AEC industry. I guess everyone knows about AEC, right? Architectural engineering and construction industry. So we use all these amazing technologies like data science or AI or high performance computing, building information modeling, then extended reality signal processing for our research projects. Um, so although Dr. Aji said I'll be discussing about LiDAR and surveying, but I'll be honest with everyone, I'm not an expert in surveying. We are not an expert. Nobody in our lab is an expert in surveying, but um, we do. I do teach building information modeling, advanced building information modeling, which is a graduate level course at UTA, um, mainly for masters and PhD student. And we teach a few topic, right? Reality capture, scan to beam, which is very close to surveying and mapping using emerging technologies. Are we all doing good here at this point? Anyone have any question? Sure, sure. Okay, so I'll go back to that question. I'll answer your question at the end. What do you, is it a good thing? What do you think? At the end of the presentation, that's a very good question. Uh, so how many of you know actually about building information modeling? Like what is building information modeling? Anyone does know about building information modeling? No one? Okay, which is good for me. Then I have something more to talk about. So building information modeling is a approach where you can generate and manage a digital representation of any physical infrastructure. So it can be a building. Like although it says building information modeling, it doesn't have to be a building. It can be a building. It can be a road, it can be a bridge, it can be any infrastructure that you can think about or you can see in the world. So the basic idea is you have to have a precise digital model of a physical element. Now, if you played game, most of you plays game, I guess at least. So you know about game physics engine, right? Where you have a physics inside the game environment. So building information modeling, what we do, we try to bring the physics of real world inside a digital environment, but for the functionalities are for infrastructure. Now, generally, when we talk about BIM, building information modeling, we only think about 3D models, so precise 3D models and everything. But BIM is 3D model, definitely. 3D model is part of the BIM, but BIM is more. BIM is a whole life cycle process of your project. Um, Dr. Islam, do you have any BIM course in BUET yet? Hello? Are we lost? Is there any BIM course in BUET?
No, so, sorry, Dr. Savi. No, there is no BIM course.
So,
Actually,
okay, okay.
in BUET, there is no construction management course at all. So
Oh, wow.
nothing
Okay. Yeah,
related
yeah,
to
yeah, yeah. I
construction
remember.
management. Yeah,
So it is the same syllabus what we had, right?
yeah, it's almost the same syllabus.
Okay, that's good. Good to know. Thank you.
Yeah, you're welcome.
Okay, so as you don't know about, as you don't have construction project or management courses, which is actually I think $2.5 trillion industry in the whole world. Um, so just try to get some idea from whatever I'm saying here. Um, okay. So the thing is here, building information modeling will be a precise 3D model, and then you add all the information. By information, I mean, if you think about a scheduling of your project, it is a kind of information, right? If you think about um, simulation or costing of your project, it is another kind of information. If you think about energy simulation of the building, it is another kind of information. So when you add all this information to one 3D model, precise 3D model, um, that includes the building phase, design phase of the project, building phase of the project, and operational phase of the projects. Then which this complete system, what we call building information modeling. So you have a model that includes all the information that you can ever think about in any building. Now, there's actually more. Nowadays, we also have digital twin, which is the precise model of BIM. So BIM starts from 3D modeling, digital twin starts after the BIM. We're not going to go into the digital twin. This is actually much more deeper technique and technology involved there. But you should at least have some idea about building functional modeling at this point. I'll also play a video here just to give you an idea. Can you hear it? Okay. Can you guys hear the noise, the sound? I'm trying to unmute it. Oh, come on. Really sorry about that. Can you hear it now?
No.
No, sir, there is no sound.
Not yet. Not yet.
No, sir.
No, no.
Okay, okay, that's really odd. Because last time I tried, it was working, and Is it better, or you cannot hear it yet? Still. Okay. So right now it's paused, but last time when it was playing, you cannot even hear it. Nothing clearly, but you can hear something or no? Um, Ajit, are you there?
No, sir.
Yes, actually, we didn't hear anything. So probably maybe while sharing the screen, is there any option to, there is one option that includes sound. If you unshare it and share it again, you will see it in the upper right corner that there is one button. You need to turn on that button that includes sound.
This one?
We cannot
let's present
see.
in panel.
Yeah. Yeah, you can stop sharing and share it again. And while sharing the content, there is one option.
Oh.
Yeah, that include
I
sound.
only can can only see standout, standby, reporter, and please on. Yes. Sorry about that. So
No
turns out
problem.
I'm not that much technical, right?
What is BIM?
Yes,
BIM is
now we
very
can hear.
much talked about
Now you can hear it, right?
Right. Yeah.
out in the building industry, but what is it really? What is it used for, and who should use it? Some say BIM is a type of software. Some say BIM is the 3D model of buildings. Others say BIM is a process, or that BIM is nothing more than an organized collection of all building data. BIM is all of the above and more. Now let's see BIM explained in layman's terms. When it comes to BIM, everything begins with a 3D digital building model. This model, however, is more than just simple geometry and some interesting textures added to it for visualization. A true BIM model consists of the virtual equivalents of the actual building sections used to create a building. These intelligent elements are the digital prototype of the physical building elements such as walls, columns, windows, doors, stairs, etc., that allow us to simulate the building and understand its behavior before the actual construction begins. Now let's see what a BIM model can be useful for. 3D visualization. Of course, the most basic use of a BIM model is for creating realistic visualizations of the planned building. Your BIM model helps your design decisions by comparing various design alternatives and for selling your design to your client, the local community, and other stakeholders as well. Change management. Since data is stored in a central place in a BIM model, any modifications to the building design will be automatically replicated in each view, such as floor plans, sections, and elevations. This not only helps in creating the documentation faster, but also provides stringent quality assurance by automatic coordination of the different views. Building simulation. BIM models contain more than just architectural data. Information about the different engineering disciplines, sustainability information, and other characteristics can be easily simulated well in advance of actual construction. Data management. BIM contains information that is not visually represented at all. Scheduling information, for example, clarifies the necessary manpower, coordination, and anything that might affect the outcome of the project schedule. Cost is also a part of BIM that allows us to see what the budget or estimated cost of a project might be at any given point in time during the project. Needless to say, the data put in a BIM model is not only useful during the design and construction phase of a building project, but can be used throughout the entire building life cycle, helping to reduce the operation and management cost of buildings, which is significantly more than the entire cost of construction. With all the benefits BIM has to offer.
So at this point, you can understand BIM is actually a management thing, right? So you have the 3D model, and I guess at if you are in 1, 2, you you already started working on the AutoCAD drawing and design. Before that, you do all this hand sketch of 3D modeling and plan and other stuff. So once you know about your 2D plan, isn't it better if you have a 3D model, computer aided design model? Like if you can make a 3D model, then you can um, have a better visualization of about your final project, what it will be, right? Now, with that 3D model from 2D plan is already giving you a better idea. Then if you add all the other information like lighting, scheduling, cost estimation, 4D simulation, then your time scheduling and everything, then you can get a much more better idea about the total project completion and project requirement, time requirement, materials requirement, and everything. So the one of the most important in building information modeling is the information which you are adding in the infrastructure, right?
Mm.
So as I said, BIM is a system. It's not just one 3D model, or it's not just one single element that we're talking about. So it starts from when you start planning. Like if you start when you started working on a 2D plan just to get an idea about your projects, then you create the 3D model of your building, then you did the simulation, structural analysis or plumbing analysis or architectural analysis, light analysis, whatever you're doing is also part of the BIM system. So all of this information at every point when you are creating a 2D plan, when you are working on a 3D structural analysis, when you are creating a 3D energy simulation, or when you are assigning all the specification of materials, then you're talking about the procurement or the material amount, quantity, or the scheduling. You're actually getting one type of information or different types of information in different phases. Even at some point, when you try to demolish this building, you also need the precise information about how to demolish it. If you don't know about the precise information of all the structure and member and materials, you cannot decide on how to demolish it or what will happen once you demolish it, right? So all this information all together during the whole life cycle of a project is called BIM system. Now, I'll I just talked about a lot of things, the bigger view of the whole beam system. But let's talk a smaller segment of this beam. Like, um, let's zoom in only in the 3D modeling. The reason only want to talk about the 3D modeling because 3D modeling is relevant to surveying and mapping more than the whole beam system, right? At this point, you can understand that. So your beam system will have everything in it, but you need a precise 3D model to actually create a BIM system. Is it clear now, right? It is clear now, right? So you have to
Yes,
have a precise.
Dr. Sakib, there is one question from one
Sure,
student.
sure, sure,
Yeah.
sure.
Yeah, Tosif, go ahead. Tosif, you're muted.
Right, right. Exactly. So one of the major use of BIM, so BIM starts before we go for the construction. So the idea of BIM is if you cannot build something virtually, you'll not be able to build it in real life, right? Real life is tougher. So we try virtual system. Then once you use some kind of material, like suppose if you think about a steel building, then the costing, you will get the material quantity, right? Because you already have a 3D model. That means you have all the quantity of all the materials that you need. Now, then you will get an idea about the quantity and you know the costing of those material, labor cost and material cost. Then you can figure out the approximate final cost of a building. Now, suppose the costing is higher than your budget. What you can do, you can change those material or the type of structure maybe the window type, maybe the door type, and get an idea of the next of the updated costing of your building, right? So BIM also helps you decide on the budget of your project. So that's very helpful, right? But yeah, BIM is actually, to be honest, if we talk about BIM in that detail, it will be the whole 2-3 hours lectures. Um, just to give you an idea, BIM is the ultimate management system for the whole life cycle of your building. That includes preliminary design to cost estimation to schedule planning to material management, logistics, and finally, even the operation. Like your BIM model will be able to tell you if you have to take care of some kind of utility system in next 5 or 10 years based on the model. The reason I wanted to give you an idea about the whole BIM system because it's important, right? But what I want you to understand, to do all of these things, you need a precise 3D model. Is it not? Okay. And precise. Right, right, right. You can always go back. Yeah, you can always go back, make a change. Right. And it will affect the whole life cycle again. No, no, no. So once you have the precise 3D model and you add the scheduling and estimation and other stuff, right? So if you think about it, if you have a precise 3D model, that 3D model have all the information of materials and geometry and everything. So next time, if you just suppose you have a concrete column and you change it to a steel column, isn't your materials is also changing? That means your estimation will automatically change, right? Yeah. So this is fun. This is actually really interesting. I'm glad that you asked this question. So another thing that I want to show you, which is a very important approach for BIM, building information modeling, is clash detection. Suppose a structural designer is creating a structural model, a plumbing designer creating all the plumbing pipelines and ducts and everything. Architects is designing all the rooms, walls, doors, windows, and everything. Now, when different people are working on one single project, there's always a chance of clashing between those elements, right? So what BIM does, once you create a precise 3D model, it can detect, identify, and solve these clashes. Like if I just give you one example here, if you look at this slide, you can see there's a red mark. It says conflict highlighted in Autodesk building system. So if you like right now, what we're using 2D printed drawings, right? So if you have a clash here, like in this 2D drawing, it's really hard to understand what's going on, right? But if you look at the 3D model here, you can easily understand that the conflict between a duct and the conduit, which is really hard for anyone to understand when you just have a 2D plan. So 3D modeling is very important for next phase or next level of management for any project, construction project. Now, you don't really have to think about this that much when you are working on a $100,000, $200,000 project, but think about $1 million project, $1 billion project. Then you don't want to make any mistake that might cost you your whole career, right? So this is where the scan to beam or reality capture comes in. So to enable a beam model, you need a precise 3D model of the infrastructure. Now, how can you do that? If your building already exists, if it's a existing structure, that means you need a as-built design or drawing for that model, right? If you want to change anything or do anything, modify anything. So this is where the scan to beam or reality capture comes in. So reality capture is a process that uses emerging technologies to digitally represent the physical space or object or any kind of infrastructure. And how we do that? We can use LiDAR, we can use photogrammetry. Uh, it also mentions drone, but drones will use either photogrammetry or LiDAR or 3D scanning to create that physical 3D model of that. And why do you need that? One of the reason, suppose if you have a 2D plan, or if you want to measure everything and create a 3D model in an AutoCAD or Revit file, it takes a lot of time. And just to give you an idea, in US, the people who actually knows this BIM or Revit, they're super costly. Like if you have a master's degree in US, like in any other field, like if you have a master's degree in construction, if you have a master's degree in structure, geotech, or transportation, the regular standard salary, I think, is about 65,000, right, Dr. Islam? It was about 65,000 to 70,000, something like that.
Yes,
But
right.
if you have a BIM experience, if you know BIM, your salary starts from 90,000 to 95,000, even with a master's degree. And I have one of my students last semester, he got a job 125, which is even more than our salary, even after a PhD. So these people are costly. Now, if you ask them to create a 3D model for your building, that will cost a lot of money. And there's always a chance of human error, right? If someone wants to do something. Now, what we do, that's why we do this reality capture, and I'll show you another video. I promise this is the last video.
At Harbor Freight, we do business differently from the other guys. We design
I don't know why there's ad. I have a premium YouTube still. I have.
and test our own tools and sell them directly to you.
Come on.
No middleman. No folks in suits telling us to raise prices for the heck of it. Just quality tools you can trust at prices you'll love throughout the Christmas season. That's how we like to do business anyway. Whatever you do it for less at Harbor Freight.
Sorry about that. Sorry? Yeah. There shouldn't be any ad. I have a premium YouTube. Yeah, BIM is a collaborative work. You're right about that. So all the people, like the structural people, guy will work on the structural analysis from his part. A architectural person will work on the plan from his or her part. Plumbing engineer will work on the plumbing engineering from his or her side, and everything will be merged in a cloud altogether. But there'll be also an authorization access. So you cannot really change something from architectural drawing or element, but you can only change the element that you are responsible for. Does it make sense? Right. Okay, this is the last video that I'll play, and this is very interesting, okay? So about reality capture, how we do reality capture.
If you work in the architecture, engineering, and construction industries, then you may well have heard the term scan to BIM. But what does this actually mean? When people say scan to BIM, they're referring to the process of 3D laser scanning a physical space or site to create an accurate digital representation of it. That representation can then be used for designing, assessing progress, or evaluating options. Now, when I first heard that, I was feeling about as confused as you are now. So here's a step-by-step explanation of how the process works and the benefits it can bring. Firstly, it's important to determine why you wish to create a digital representation of a space and to be clear about what you will use that data for. If the team you commission to undertake your survey know what it needs to be relied upon for, they can ensure you receive a scan that best meets your needs. In this example, we've commissioned a scan of a heritage building, the beautiful St James's Church in the heart of London. The scanning process can in theory be undertaken by just one person, though this is dependent on your site and the outcome of a thorough risk assessment. Using a standard tripod, a 3D laser scanner is attached. Scanners like the Trimble TX8 demonstrated here, come in easily portable cases and weigh around 11 kilograms. Before a scan commences, some key parameters need to be entered into the scanner's touchscreen interface, but we'll explain more about these a little later on. To capture a digital representation of a space, a laser within the scanner case rotates at high speed. As the invisible laser beam hits various objects or materials, their position relative to the scanner and to other elements of your site or building is recorded as a piece of digital data. This is known as a point. When several of these points are collected, they begin to build a highly accurate three-dimensional digital picture of the space or site being scanned. A large collection of these points is commonly referred to as a point cloud. Now, it might sound obvious, but the more points you collect, the greater the accuracy of your scan. This is commonly referred to as a scan's resolution. There will be times when you need the highest possible scan resolution, but this isn't always necessary, and it comes back to determining what you want to use the scan data for right from the outset. The scanner automatically rotates during the scan process to capture the area being scanned. It may perform a complete 360-degree rotation or a lesser turn, depending on the data to be captured. The Trimble TX8 can capture points up to 340 meters away with its extended range. The scan area and your desired resolution are all entered as part of that parameter data we mentioned earlier on. To give you some idea of the magnitude of data collected during a typical 3D laser scan, the Trimble TX8 collects data on 1 million unique points every second. That's around 300 million points during a 5-minute scan. 3D laser scanning removes a large degree of human error from the surveying process and enables significantly higher volumes of data to be collected over a considerably shorter period of time. This means that survey information can be relayed to project teams faster. It also enables surveyors to undertake more scans than they could have done previously. The lasers used within 3D scanners are of no risk to people or animals and cannot materially affect or damage a building's fabric. This is a particularly important consideration when working with heritage schemes like this one. A high-resolution camera on the front of the Trimble TX8 scanner captures images of the scan area simultaneously to the laser scan. This enables the scan data to be colorized at a later stage, creating a realistic render. The laser beam emitted by the scanner can only travel in a straight line from the spot where the scanner is positioned. Therefore, to build a complete digital representation of a site or building, multiple scans will need to be undertaken from a variety of locations, ensuring complete coverage of the space. This is another reason why it's important to determine the objectives of your laser scan from the outset. You don't want to scan more areas than are necessary.
So now, as you have a basic idea about reality capture, you can understand that we are using laser scanner to scan something. And I know that was British accent. You might face issues to understanding British accent sometime, but I'll share this link with everyone so that if you want, you can go back and check the video. We recently bought that laser scanner you just saw there. It was about $85,000. Dr. Aziz, I think you saw the laser scanner, right? So we're using the laser
Yes,
scanner.
right.
Yeah, we are using the laser scanner from this semester in our BEAM class. So a student can actually use the scanner and create a 3D model of any building or element or room. Now, what it does, the basic concept of this laser scanner or LiDAR, what we call light detection and ranging system. So there are different laser scanner, different type of laser scanner. One that we are using, or you saw already in there, there's airborne laser scanner, which generally are mounted to a airplane or fighter airplane or something like that. There's car laser scanner, car LiDAR. Car LiDARs are generally we use in the automated cars like Tesla cars. They stopped using LiDAR from last 2 models, but they used to use laser scanner. Other automated car, they use laser scanner. So the basic concept or principle of this laser scanner, using this laser scanner, is very straightforward. So this device, it shoots a laser, and when the laser ray reflects back, it estimates the time, travel time, from shooting the laser and reflection of getting back the laser after the reflection. And based on that, it determines the location of that point where it reflected from. Now, as you can see, as you remember, if you remember from the video, this laser scanner rotates 360 degrees horizontally and also 270 degrees vertically. So that means it's kind of uh, scanning or shooting lasers 360 degrees vertically, sorry, horizontally and 270 degrees vertically. So it's shooting laser everywhere in the room, right? If you place it in the middle of a room, it will shoot laser everywhere. Now, from there, from each, and it shoots about 1 million laser per second, which is huge. So think about how many points it's shooting every second. And if you get an idea about all these distances of this point, like if you place the laser scanner in the middle of a room and it shoots laser towards all the wall and gets an idea of the points, all the points that you have on these walls, and if you place it in a 3D space, you literally can get a 3D surrounding model of the room itself, right? And this is what also you can do when you are scanning from a airplane. If you want to scan a landscape using the laser scanner, it's the same methodology. So we have this laser scanner. What we do, we place this in a position where you can scan it from or where you want to scan something. Then it shoots all this laser and it creates all this point. And if you accumulate all the point it shoots and collects, you get the point cloud. And then the recent software, they're much more, they have better connectivity, and you can just transfer this new point cloud to a Revit or 3D AutoCAD or Autodesk software to create a 3D model, precise 3D model out of it. Even there are some software that can instantly convert your laser point or this point cloud to a 3D model. And I'll show you one example. So this is a scan, point cloud scan, or what we call reality capture laser scanner scan from a construction site. Can you guys see these columns with reinforcement, exposed reinforcement? Also, there are some exposed reinforcement. They recently did this, casted this slab, right? So from here, what you can do, you can get a clear idea and precise idea and measurement of the surroundings. Like you can literally, if you bring this point cloud into a software, the reality capture software, you can measure the dimension, the height of this reinforcement from there, and that will be precise dimension. Um, Now, another use of this kind of, yes. Right, right, right. Right, right. When there's, so if the points, it can only reflects back or read until 350, but there are actually laser lidar scanner that can go up to 1,000 meter. But the one we have, it can go up to 400 meters. So if it cannot get the point from there, there will be no point. So it will appear as a black. But just hold on a few minutes. There will be more example that I'll be showing you that will make things a bit more clear. So just to give you an idea, once you have a 3D precise model of the surrounding you have, the possibility can be huge, right? You can add new element and try to check if how this new element will fit in your existing model, right? And you can try different things. Like suppose another thing that we talked about is uh, laser, this lidar or laser scanner, they shoots laser only straightforward, right? So suppose if you are scanning something from outside, that's easy for you. You can just scan it. You can just place the laser scanner outside and you scan everything. Now, if you want to scan something inside, like suppose if you want to scan the whole civil engineering building that you have, but how can you do that? If you place your scanner in the middle of that, the ground floor that we have in civil engineering building, right? We have two labs in two sides, and there's a middle huge opening, double height opening in the middle, right? So suppose if you place the laser scanner in the middle of that place, it will be able to scan whatever will be within the straightforward range of the laser, right? But what if you want to scan something, inside of a room, what do you have to do then? Now, this new laser scanner, they're very precise. All you have to do, if you look here, if can you see these triangles, blue triangles with red points? So these are the points where you'll place your laser scanner. The idea here, when you're placing this laser scanner in this point, it will, can you see? Okay, yeah, when you are placing your laser scanner in this point, it will actually, sorry, my bad. Okay. So when you're placing this laser scanner in this point, or I can mark it with a pen, I guess, yeah. So it will scan everything surrounding it, right? But if you want to scan this room, what you have to do, you have to place this laser scanner somewhere here in the middle where the scanner can see the previous location and will also scan the new location. Then if you place the laser scanner again here, it will scan this previous location and also scan the whole building. And the new software, the reality capture software, it will remember the first location that you have here, second location you had here, and third location you had here, and it will automatically overlap all the point data that you collected and create a precise 3D model out of it, which is amazing. So this is one example, Dr. Aziz, Dr. Islam, I think you remember this place, right? This is the UTA
Yes,
Tower.
definitely. Yeah.
Yeah, this is actually the best place to take all the picture for any graduation. So you can see this UTA tower in real life, in picture in the left side. We use this Trimble X9, which is even as more advanced than the one in the video, X9. I think it collects about 1.2 million data point per second. And we use that to scan this whole tower. And if you look at here, you can see this 1, 2, 3. I'll actually use the laser pointer. So you can see this 1, 2, 3, 4, 5, 6. So these are the places where we had to place the laser scanner to complete scanning of the whole tower, because when you put the scanner in the one, it cannot see what you can see from point 4, right? Because it's on the other side of the tower. So we had to put it in different angle, in different locations, so that we can surround the visibility from all 360 degrees of this tower. So we did that, and this is a precise 3D model. We also measured it, how precise it is. And just to give you an idea, this measurement using laser scanner and real life actually varies 0.001 or 0.01 millimeter to 0.001 millimeter. So that's very precise for this kind of application. Now, I'll also talk about a bit about photogrammetry, and most likely we're almost done, and I think the time is also almost done. So after that, I'll just show you some projects that we're doing right now and then go for the question answer directly. So photogrammetry is another technique, but as you remember, in reality capture, we used LiDAR or laser scanner, so it is more precise. But in photogrammetry, what we do, we use images. So instead of using LiDAR, we use photos. That's why it's photogrammetry. And if you look at that picture in the left side, the bottom left side picture, you can see the difference, a basic difference about LiDAR and photogrammetry. So with a LiDAR, you can just scan everything using a laser. But in a photogrammetry, you have to take pictures. And when you are stitching these pictures together, because your picture only every picture have a frame size, right? It can be 1440, like 144p or HD, whatever it is. So there's a pixel size or frame size of every picture. But the technique here is when you are taking a picture and then you are taking another picture, you have to have some kind of overlap in between those pictures. So once you have the overlap, then the software, using some software and other algorithm, you can easily stitch them together where they match with each other. So using photogrammetry, you have to take several overlapping picture. And as you can understand, this is picture, so the 3D model will not be precise like you have precise laser scanner data. It will not be as precise as that, but it works perfectly fine. Uh, Especially with the new algorithm that we're using, structure from motion, creating a 3D model from hundreds of thousands of 2D picture is very reasonable nowadays.
Dr. Sakib, I think you are muted now. Somehow you got muted.
Am I still muted?
Now we can hear.
Oh, sorry about that. I don't know how this happened. So how far you guys were able to listen? Photogrammetry?
Photogrammetry, we already
Okay,
listened
so
to it.
the idea about photogrammetry is very straightforward. If you want to create a 3D of this cube, you have to take a picture from, like suppose if you are taking 3 pictures from 3 different angles, but always you have to, in every picture, you have to have some common point, so that when you are taking a picture from camera 1 angle, and you are taking a picture from camera 2 angle, and you are taking a picture from camera 3 angle, or PI angle, whatever it is, they have to have a common point that your algorithm that you'll be using to stitch this picture together can find. So you have to define this is the same point, Q11, and Q21 is the same point from camera 1 and camera 2 angle. So the algorithm is very complicated. I'm not going to explain how the algorithm works. It's a lot about machine learning there. But if you're very interested, feel free to email us, me or my student. They can explain it better. And there was a example of using images to create the Colosseum, if you know about this. So what they did, I don't think you guys know about Flickr, right? Flickr is kind of Instagram in 2010 or 12, something like that. So they collected about 150,000 images from flickr.com. And what happens in flickr.com, if you upload an image, it will record the GPS location of your image. And this small camera, this black thing that you can see are the camera position of all these images that are here in the left side. So what researchers did, they took all this picture and they pointed out the location that picture was taken from, and they used the algorithm to place all the picture together and finally create a 3D model of this Colosseum just from this 2D picture, which is amazing. Uh, Another example here. So this is a construction site that you can see, and we have hundreds of thousands of pictures from this construction site. And from this image, all the images, just from the images, you can create a precise 3D point cloud, similar like LiDAR point cloud of this whole project. It will not be as precise as LiDAR point cloud, but you will have an idea about the surrounding. Now, how can you use it? Suppose if you think about the transformation that we're having here, you are taking a picture and then converting it to a 3D model, right? Now, if you have a 3D model, and if you already had a 3D beam model, and right now you have a new updated model that is actually real in your site, you can always compare this new on-site 3D model that you got from the pictures, that you created from the pictures, with the beam model that you have. Okay, let me try to explain it again. So you have a precise beam 3D model that you know, and you have a schedule. You know how much work you should have done by today. And now using a video camera or webcam or CC camera from your site, you can also get an idea about the current progress of your project by taking those picture and converting those picture to a 3D model. Now you have a 3D model from today, and you also have a 3D model of how much progress should be there by today, and you can compare them and define what is the current progress. This red portion of the site is behind schedule, and this green portion of the site is on the schedule, and this dark green is ahead of the schedule. So the software or a computer vision software can easily compare in between the BIM model that should be done by today and the current progress of your site, and give you an automatic alert or report about what is the progress in your site right now. Now, this is a project that we're working right now with for the University of Texas at Arlington. So we're trying to create a dynamic map. Do you guys have an idea about PCI, pavement condition indexing? I think it's you'll read it in third or fourth year. So what we're doing, we're flying a drone above all the parking lot that we have in UTA, and this drone have both RGB camera and thermal camera, and they're taking all the picture like you can see here. The left one is a RGB camera and the right one is a thermal camera. Here also in the left one RGB camera and right one is a thermal camera. And you can see the same crack of this pavement are even more prominent, or some hair crack that you cannot see in real life, or here some differences in temperature or some things about that you can easily identify in the thermal camera, which you cannot in real or RGB camera. So what we're trying to do here, we'll just fly a drone. The drone will be, we'll fly the drone like in different time period, different month, maybe once a month or something. And it will fly over the whole parking lot, and it will get an idea and give a feedback to the parking lot authority that, okay, you have severe damages in this segment of the parking lot, and you should um, take measures or solve it or do something about that as soon as possible. So it will be a dynamic map that we're creating. So the map, if they click on different portion of the problem that they have, it will pop up and show them the exact problem and how they can solve it as soon as possible. This is a project Sean Joy, who is also ex-Boetian, he's working on. Another project that I would like to talk to you about is 3D thermal scanning to detect building energy performance. So this is where we are doing the photogrammetry. So if you what we're doing, we're taking a lot of 2D images of the surrounding building. And Dr. Aziz, hopefully you remember this. This is the Trinity Hall that we have on campus. So we took a lot of 2D images, RGB images, and thermal images. And then using these 2D and thermal images, we developed a precise 3D point cloud of the building. And then we overlap these thermal images. Thermal images are actually the surface temperature of building. And you can capture it using thermal sensors that we also have in this drone. These drones are also very costly. They have this thermal sensor already built in there. So this thermal profiling, the images that we're capturing, we're trying to overlap these thermal images on this precise 3D model, and you can see the final result here on the right side. So in the right side, it is the overlap of precise RGB model and the overlap of thermal values of the surface. Now, how does it help? Now you can see, if you look carefully.
Dr. Sakib, just a quick question. Should I stop recording the session?
No, this one is fine. I know this says confidential, but this one is actually fine. This one already published. Thank you for asking.
No problem.
So if you look carefully, you see some of this portion of the building are green. So green means there's low temperature. If you look at the red, this side on the right side, those are red. You also have some red in this side of the building. That means the building surface in those sides are hotter than the green side or the blue sides of the building, right? So what we did, We have a precise 3D model and we overlapped all the temperature value on top of this building. That's it. Now, the way it can be helpful is, um, so most of the building in US are central AC controlled. So we control AC centrally. So that means those are huge HVAC system, and the costing is also huge. Now, if there is any leakage, thermal leakage or AC leakage or something happens in this huge building, it will be really hard for anyone to find it out manually. Now, what happens? Our drone just flies over this building and creates this precise 3D model, which is a 3D model plus the thermal value. And if you have any defect in any location, like if you look here on the right side of this building, that means something is wrong in this side of this building. Because this side of the building is green, this side is too red. So that means either this is not insulated properly or something is not right there. So this is how you can find or detect any energy performance of the building or take measures or retrofit your building based on the requirement. Um, so this is actually some of the previous projects. I'm not sure, Dr. Ajit, I don't think we have much time about showing them the previous and current project, right? I think we're already past 10.
Yeah, but we are available if you can show us. Yeah,
Yeah, I
most
can
of
I
us
can.
are available now. Yeah.
So if you students যারা স্টুডেন্ট আছো তোমাদের তোমরা যদি অ্যাভেলেবল থাকো right now we are done with the presentation what was supposed to do like mainly LiDAR scanner এবং photogrammetry. So আমরা ওইটা ডান। এখন আমি মেইনলি আমরা যেগুলা কাজ করি ইউটিএতে which is like তোমাদের সিনিয়র ভাইয়েরাই করে বুয়েটি and তো যে জিনিসটা বলতেছিলাম যে this is actually one of the most popular project that we had. So what we did here is as you can see, তো আমরা একটা ভার্চুয়াল রিয়েলিটি বেসড ট্রেনিং সিস্টেম ডেভেলপ করছি। সো এই ভার্চুয়াল রিয়েলিটি বেসড ট্রেনিং সিস্টেম ওয়াজ অ্যাবাউট training. There's two training system we developed. One is for the student for their public speaking anxiety. So we used a virtual reality based training system, and we used wearable devices to understand human factor, their stress level, their performance level during a public speaking training. And um, I if you don't, I think everyone can understand that public speaking is one of the most um, underrated fear that we have. Everybody have some kind of public speaking anxiety. So this project was really successful. It was one of the most popular project in the whole university. All students wanted to try this to reduce their public speaking anxiety. Um, Another project that we did, we developed a training simulator for veterans, ex-military people, when they're transferring from their military career to civilian career, because it's very hard to understand and connect with civilian population when you're coming from a military system. So we developed a training system for them also. Another previous project was where we developed a drone flying training system. So we developed this drone training system in the virtual reality. So you can fly a drone inside the virtual environment before you actually fly the drone in real life. We also used a lot of wearable devices, facial expression, their speech expression, their movement, acceleromotion, and a lot of other things uh, to identify their performance and stress level. So from the virtual environment, from their performance, we we were able to detect or predict how good they will be in when they'll be flying this drone in real life. So that was a really, really successful project that we had. Um, Another project, oh, really noisy, sorry about that. So another project here you can see, so we let people, so we developed this flooded environment. And I know Bangladesh also have this similar situation for flood is a big issue in Bangladesh also. So in Houston, in Texas, Houston, flood is also a really big issue here. So we developed this flooded simulation in virtual reality for people to walk around inside the flood zone. And we are try to understand human perception when they're walking around this flooded environment. Another project you can see on the right side that we developed so we used a two drone system. So there'll be a primary drone and there will be a sentinel drone. And the task was here that this two drone, this is actually a mapping problem, which was really nice. So this two drone was connecting with each other. One was working on visual slam, another one was working on LiDAR slam. So we had a photogrammetry drone and we had a LiDAR drone. They were both connected and contacted with each other. And then they both created a 3D map of this area, and we merged that visual or photogrammetry and LiDAR um, map together to get a precise 3D map, and then we passed it to the first responders. So the idea was, if any fire incident happens anywhere, then instead of the first responders like firefighters or police, instead of they going inside first, we can send these drones, and this drone can create a precise 3D model of the inside area of this fire incidented area or structure or whatever it is, and send back a precise 3D model or map to the people who will go next to help or do whatever they will be doing. So it was a great project, and to actually serve the first responders. And I think this kind of project can be very useful for Bangladesh also. So one of the ongoing research project, I can also show this one. So this is as if you look carefully on the right side, can you see?
Dr. Saki, no. All right.
So you can stop recording after. I'll actually tell you. So don't worry. Thank you.
Okay.
So
Okay.
if you look carefully here, this is actually a very fun project. So can you guys see that three people are working on the same robotic arm, which is really amazing, right? So this robotic arm is not real. And if you look on the top side, this is a rover, and two people are, and this is a virtual rover. This is not real rover. This is a virtual robot, and two people are working on the same robot in a virtual environment. And this is what we call mixed reality. This is not virtual reality. Mixed reality is when you have the real environment. So you bring the virtual element in the real environment, and you can interact with that. How many students we have? Dr. Islam?
57
Oh,
now.
wow. Okay. I hope they're not sleeping, at least. Anyway, but this is actually fun, you know? So what we're doing here, so I guess you cannot understand because, so look at the video, this is actually my view. So I'm looking at the same element that the other guy there is also looking at. So if you look here, this guy and this guy is looking at the same robot, and this guy is actually my point of view. So we developed a system where 3, 4, up to 10 people can work on the same robotic arm in a virtual environment. And this virtual environment is not actually in virtual environment. This virtual environment is plotted in your real life table. So this is the real life table, and this robot is virtual, and it is on top of the real life table, and you can interact with that. And along with that, what we did, we connected generative AI. Nowadays, everyone knows at least ChatGPT, right? So what we did, we added generative AI to guide these people to operate this robotic arm. So if you are doing anything wrong, the generative AI will continuously look at your task, continuously observe you, and it will guide you how you can work better with the robotic arm. This was a very exciting project for us. I think we already talked about this project. I think we already talked about this project also. So these are the devices that we use in our lab. Like we have several high performance computers, drones, laser scanner, and wearable devices, VR and mixed reality and extended reality goggles. Um, as I said before, I teach this advanced building information modeling, and some of the students' projects are amazing. These are actually the project from the class, which I'm really proud about. And they're using the reality laser scanner to lab. And I don't know if anyone knows about Abir or Sanjoy. I think Abir is 11 batch from civil engineering, and Sanjoy is 17 batch from civil engineering Buet. And they're also working in amazing things. So Abir is working on mixed reality, robotics, automation, and digital twin. But Sanjoy is working on generative AI, drones, and human factors. Um, Now, feel free to ask any question about anything that you have in your mind, or feel free to send us an email if you want to discuss about anything. So at this point, my regular presentation is done. Um, Dr. Ajit?
Yeah, all right. So I will stop recording the session.
Right. So if students are interested, I can also show a few other projects that we're working right now. Are you guys interested? Or if you have any question, you can ask me. Both works for me. Do you guys want to see the new other projects, or you guys want to ask question? Whatever you want. Okay, so you want to see the new projects, or question about previous ones? Okay, okay. Isn't it too late? Aren't you guys should? Okay, now I remember in Buet we used to go to sleep at 2. Yeah. Anyway. Oh, okay. So you don't get those 1-2 week anymore, right? Okay, okay. So the tradition of postponing exam is not there anymore, I hope. Okay. Right. Oh, yeah, yeah, yeah. I wanted to talk to you about that. Yeah, yeah, I heard about it. It's really unfortunate. I heard that one of the student from 22 batch, he died, and another student, 21 batch. Okay, sorry about that. Another guy is really injured. Yeah, I was following the details, and really sorry about that. And it's very unfortunate. And someone is trying to save the guy who caused the accident, which is awful. And yeah, right, right. Mm-hmm. Right. After the dope test came positive, it's a murder, right? If the dope test came positive, it's a murder. But anyway, it's definitely. I hope the system is much better right now, the country to solve it. Yeah, that's very unfortunate. Right, right. No, no, definitely, definitely. Right, right, right. Yeah. So one suggestion from after graduation is as soon as you graduate, as soon as you will get all the good things in your life. It's just stuck there, right? But yeah, but is the best time we ever had. Anyway, so I'm sure I'm really sorry and innalillahi rajiun for I forgot his name. Mustasim. I saw his name. I forgot. Sorry about that. So hopefully Allah. He was a Muslim, right? Hopefully Allah will take him Jannah. And আমরা সবাই এটাই হোপ করতেছি যে উম, যেটা there'll be a justice. There should be justice. There is no other way. Okay, let's move forward. তো আমাদের যেগুলো কারেন্ট প্রজেক্ট যেগুলো আমরা কাজ করতেছি তার মধ্যে এটা একটা প্রজেক্ট যেটা আবির মেইনলি লিড করতেছে রাইট নাও সো right now what we're trying to do here is we're not recording, right, Dr. Islam?
No,
Okay.
we're not
Awesome,
recording.
awesome.
We are still
So what
recording.
we're trying to do here, right, যেমন like you use AutoCAD to create a 2D plan, right? So what we're doing here, from 2D plan, you can create a 3D model, but you have to actually draw those walls, doors, windows, and everything. So what we did, we merged generative AI with Revit and other 3D AutoCAD or CAD softwares. So what happening here, if you have a 2D plan in a sketch drawing, or if you have a 2D AutoCAD drawing, you can just put it inside and then talk with the system. So if you just tell it, please create a wall or just make a house using this type of wall, using this plan, it will do it for you just by controlling your voice, just by your voice command. So we are trying to automate the whole 3D modeling process because we found this is a huge time consuming task for people who already know how to do this, even especially for newcomers. So suppose if you have no idea about how to create a 3D model, it's really tough for you. So using the system that we're generating or creating, you can just speak to the software, say that, okay, I need a building with this many room or this many floor with this type of wall, this type of door, this type of window, and it will automatically generate the 3D model for you. And you can get inside the model and ask to replace any element or material. So instead of doing it with your hand, you can just command it and it will do for you. Another project, like, I don't know how many of you know about deep learning or AI. You have at least some idea about AI, right? And one of the challenge all of you know that AI has is the requirement of data. So if you want to work in AI or train a model, artificial intelligence model or deep learning model, you need a lot of data, right? But we don't have enough data in real life. So what we are doing here, we are using generative AI. As you know, generative AI can actually create any kind of data that you need. So there's a gap of, so we need data for to develop a deep learning model for safety, but we don't have enough data. But generative AI can create the data, right? So we're trying to connect these two pipeline where we are generating this required data set in realistic data set. Like if you look at these images here in the bottom, these are all generated image. These are not real life image, but they're as real as the construction site or industry has. So we are creating this huge data set to solve the problem for any deep learning model. This is another project. So this is a project that we're working with US DOT, Department of Transportation. So we're developing a digital twin. So if you guys have an idea about digital twin, like BEAM is a precise digital representation of one infrastructure system. That's it. But digital twin is a digital representation of everything surrounding you. So we are creating a digital twin using portable sensor systems. So there'll be a different portable sensor system surrounding the construction work zone. And this sensor have proximity alert, it has LiDAR, it has camera, it has Wi-Fi, all kind of sensors that you might need for safety. And if you look here, these are placed here, and this is the construction zone. So this portable devices, they will create a digital twin of the construction work zone, and they'll observe everything, all the safety issue that is happening inside the work zone and also outside the work zone. So suppose if someone is driving really quickly, um, and someone is driving really fast, and it might cause an accident with the work zone, the people who are working in the work zone, right? So this system will automatically detect and alert everyone, both the driver and the people inside the work zone. This is a very interesting project that we're working with City of Fort Worth. So we created a digital twin of traffic intersection, like maybe it might be different in Bangladesh. Last time when I was in Bangladesh, we don't really use traffic signals in Bangladesh, right? But here, everybody uses traffic signal, which is nice and it helps. So what we're trying to do here, so these traffic signals are generally, they maintain a regular timeline, like after 1 minute, it will be green, something like that, or after 2 minutes, it will be red or something like that. So what we're doing here, sometime when the traffic flow is different, like during the office hour, everybody wants to get out of the city. During the office hour, everyone wants to come inside the city. And after the office hour, everyone wants to go outside of the city, right? So what we're doing here, we are using this computer vision, camera, LiDAR, scanner, and all the other things to detect the current condition of the road or that traffic signal in real time. And based on whatever we get, like we are changing the traffic signal automatically based on the requirement. And it can be huge. The usefulness of this can be huge. Like think about someone, a ambulance is waiting in a traffic jam, or a police car is waiting in a traffic jam, or a fire service vehicle is waiting in a traffic jam. So what will happen? This system will automatically detect these emergency vehicles, and it will open that traffic signal for them. And not just there, but also it will open up the whole traffic signal for them so that they can reach to their destination. So this is it. This is what we are doing right now in our lab. And to be honest, this is all the product of amazing Buetian student like you guys are. Two of my student, PhD student, they're super smart and really hardworking. And I guess you will be the same once you graduate, right? You'll also, if you go for higher studies, if you go for jobs, Buetians are they're superior everywhere, in academia, in industry, everywhere, and I hope that you will also continue that. Thank you, everyone. Any question? রাইট। সো আমি যখন থার্ড ইয়ারে ছিলাম তখন আমি শুরু করছিলাম আসলে এন্টারপ্রেনিউরশিপ। আমাদের এটা ছিল একটা কনসাল্টিং ফার্ম, ইকোস্ট্রাকচার প্রাইভেট লিমিটেড। মেইনলি হচ্ছে আমরা গভর্নমেন্ট প্রজেক্ট গুলোর কনসালটেন্সি করতাম। তো তোমার আমরা এডুকেশন বোর্ডের বেশ কিছু প্রজেক্ট করছি, এডুকেশন বোর্ডের, তারপর পাওয়ার বোর্ডের বেশ কিছু প্রজেক্ট। So it was, we started in 2010, I guess, and in 2013 we became actually a big company, like quite big company. We had about 128 sites in Bangladesh, in different jela. It was the ICT training center, and we had about, so it was mid-range company, not a huge one. And but another company that I started was TriFX, which was an animation firm. Like if you see, if you ever search for animation for um, like elevated expressway, then animation for Dhaka Chittagong expressway or highway. So all this animation, we created those for roads and highways and bridge authority, right? তো এক্সপিরিয়েন্স হচ্ছে যে বাংলাদেশে যে কোনো কাজ আসলে অনেক, মানে কোন এক্সপিরিয়েন্স যেতে চাচ্ছে, ভালো না খারাপ, অনেক ধরনের এক্সপিরিয়েন্স। রাইট রাইট, হ্যাঁ তখন একটা, হ্যাঁ ব্যাচেলারে যখন আমি থার্ড ইয়ারে ছিলাম তখন আমি শুরু করছিলাম। কারণ হচ্ছে আমার আমার যে, তবে হ্যাঁ বাংলাদেশে বিজনেস করা, যে কোনো জায়গায় বিজনেস করা, ওয়ান অফ দ্য মেজর জিনিস আসলে লিঙ্ক, রাইট? কানেকশন থাকতে হবে, ইউ হ্যাভ টু হ্যাভ দ্য কানেকশন। তো আমার তো কানেকশন ছিল না, বাট by that time I learned how to use ETABS and StatPro structural analysis. তো আমি এক সিনিয়র ভাইয়ের সাথে কাজ করতাম, উনি 02 ব্যাচের ছিলেন। ওনার সাথে কাজ করতে করতে আমি স্ট্রাকচারাল মডেলিং অ্যানালিসিস শিখছিলাম। আর আমাদের একজন পার্টনার ছিলেন, উনি আমাদের থেকে 18 বছরের সিনিয়র ছিলেন, যার আসলে মেইন কানেকশন ছিল। তো উনি প্রজেক্ট আনতো, আমিও ভাইয়ের সাথে কাজ করতাম। দেন আস্তে আস্তে আমি গ্রাজুয়েট করার পর আমরা যখন অ্যাকচুয়ালি জিনিসটা বড় হয়েছে আর কি। এটা একটা বড় সমস্যা দেশে। আনফরচুনেটলি আই কুডেন্ট কন্টিনিউ। আমার প্ল্যান ছিল এসে ডিগ্রি নিয়ে আবার যাওয়ার, যেটা যেটা যেমন ধরো তুমি যদি ওয়ার্ল্ড ব্যাংকের কোনো প্রজেক্ট করতে যাও, ইউ হ্যাভ টু হ্যাভ সাম ডিগ্রিজ, মাস্টার্স ডিগ্রিজ অ্যাট লিস্ট। আর বুয়েটে মাস্টার্স ফিনিশ করা খুব টাফ, হুইচ আই ফাউন্ড ওয়েন আই স্টার্টেড। তো আমার টার্গেট ছিল আমি এখানে এসে মাস্টার্স করে চলে যাব। যে আহ, আহ, মানে যেগুলো হচ্ছে আমরা লাস্টের দিকে আর কি, আমরা গভর্নমেন্ট প্রজেক্টের চেয়ে ওয়ার্ল্ড ব্যাংকের প্রজেক্ট গুলোর দিকে বেশি আগ্রহী হয়ে গেছিলাম। মানে সরি, লোকাল প্রজেক্টের চেয়ে ওয়ার্ল্ড ব্যাংকের প্রজেক্টে বেশি আগ্রহী ছিলাম। তো সেজন্য আসলে ডিগ্রি লাগে, হায়ার এডুকেশন লাগে কনসালটেন্ট হিসেবে কাজ করতে গেলে। পিএইচডি ডেফিনেটলি বেটার, আর না হলে অ্যাটলিস্ট সাম কাইন্ড। এবং আমাদের সাথে বুয়েটের কিছু ফ্যাকাল্টি কাজ করতেন, সিনিয়র ফ্যাকাল্টি, উইচ ওয়াজ নাইস, হেল্প করতেন আমাদেরকে। তো ওই ডিগ্রি নিতে আসার পর যেটা সমস্যা হয়েছে যে আফটার ফিনিশিং মাই মাস্টার্স আমার সুপারভাইজার অফার দিছে যে আর 3 বছর থাকো, পিএইচডি দিয়ে দিব। তো আমি 3 বছর থাকছি পিএইচডি নেয়ার জন্য। বাট এর মধ্যে যেটা হয়েছে যে আসলে দেশে ফেস ভ্যালুটা খুব ইম্পর্টেন্ট। ফেস টু ফেস না থাকলে বিজনেস টিকায় রাখা টাফ। তো আমার পার্টনাররা সবাই ইন্ডিভিজুয়ালি ভাগ করে নিয়ে চলে গেছে তাদের শেয়ার। তো উই স্টিল হ্যাভ দ্য কোম্পানি, উই স্টিল হ্যাভ দ্য কোম্পানি। আমরা এখনো কিছু ইয়েদের ফিডব্যাক দিচ্ছি, যাদের প্রজেক্ট আমরা গভর্নমেন্ট প্রজেক্ট করছিলাম সেগুলো এখনো ফিডব্যাক দিয়ে যাচ্ছি আমরা। বাট আফটার দ্যাট ইটস গন। I mean, you need people. তুমি একা কোনো কিছু করতে পারবে না, রাইট? মানে ইউ নিড রাইট পিপল। মানে রং পিপল হলে আবার উল্টা সমস্যা তখন আবার। যেমন আমাদের, ওকে, জাস্ট টু গিভ ইউ অ্যান আইডিয়া, I started about 13 different companies when I was in Bangladesh, uh, from my third year up to 2018. Yeah. ফ্রম 2010 থেকে 2018 মধ্যে আমি অ্যাটলিস্ট 12টা থেকে 13টা কোম্পানি চালু করছি, তার মধ্যে 3টা থেকে 4টা চালু থাকছে এবং একটা ছিল প্রফিটেবল। সো ইউ হ্যাভ টু কিপ ট্রাইং, রাইট? আর ইভেন আর ইউ গাইস এখানে কি কেউ বুয়েট ক্যারিয়ার ক্লাবের সাথে ইনভলভ আছে? আচ্ছা, তো এটা যাই না, এটা রিলেভেন্ট না, তারপরেও আমি হচ্ছে ক্যারিয়ার ক্লাবের ফাউন্ডার ছিলাম, ফাউন্ডার প্রেসিডেন্ট। তো আই থিংক ইটস জাস্ট
ওরা এখনো 1-2 তো এখন আর কি এটা ইম্পর্টেন্সটা বুঝে নেই আর কি,
এখনো
একটু
বোঝা নাই,
উপরে
right?
লেভেলে উঠলে তখন ক্যারিয়ার ক্লাবের সাথে ইয়ে হবে।
আমরাও তো ক্যারিয়ার ক্লাব,
হ্যাঁ।
আমি তো শুরু করছি যখন আমি ফাইনাল ইয়ারে ছিলাম, 4th ইয়ারে ছিলাম, তখনই শুরু করছিলাম ক্যারিয়ার ক্লাব 2010-এ মনে হয়, রাইট? ব্যাড এক্সপিরিয়েন্স যেটা বাংলাদেশের সবচেয়ে বড় সমস্যা, সেটা হচ্ছে সবকিছুতে তোমার আহ, কোনো কিছু স্ট্রেট ফরওয়ার্ড যায় না আর কি, না? there is always the speed money is there, right? তো ওইটা আসলে খুব মানে টাফ ম্যানেজ করা, and you don't know how to overcome that and manage that. তো প্রাইভেট প্রজেক্ট আরো বেশি এগুলা। তো মানে করাপশন জিনিসটা আসলে সলভ না করলে খুব টাফ দেশে কাজ করা। আর ইভেন আমি তো মানে যেটা হচ্ছে যে চেষ্টা করতে হবে, মেইন ব্যাপার হচ্ছে গিয়ে চেষ্টা করে যেতে হবে। এবং দ্য রিজন আমি বিজনেসে গেছিলাম কারণ হচ্ছে আমার মনে হয়েছে যে অ্যাজ এ ইঞ্জিনিয়ার you are capable enough to feed yourself, your family, you are capable enough, and it's nothing actually. বাট তুমি ভালো মতো যদি চিন্তা করো যে তুমি বাংলাদেশের বেস্ট ইউনিভার্সিটি থেকে পড়াশোনা করে যদি 8-10টা মানুষের উপকার করতে না পারো, তাহলে কি লাভ, রাইট? খালি নিজের সংসার চালাচ্ছ, নিজে খাচ্ছ, পড়ছো, ঘুমাচ্ছ, ভালো। আহ, সেই তুলনায় তুমি যদি একটা স্টার্ট আপ দাও, একটা অন্টারপ্রেনারশিপ করো, তুমি 8-10টা মানুষকে টানতে পারবা, রাইট? তাদের ক্যারিয়ার দেখতে পারবা, ফিউচার দেখতে পারবা। দ্যাট ওয়াজ দ্য মেইন গোল আই হ্যাড। তো ইট ওয়াজ রিয়েলি টাফ, কারণ আমার টিউশনি করানোর টাইম ছিল না আসলে এগুলোর পিছনে দৌড়াতে দৌড়াতে। ক্যারিয়ার ক্লাবটা আসলে আমরা বিল্ড করছিলাম ওই জন্যই। ক্যারিয়ার ক্লাবটা মেইনলি টার্গেট ছিল যে যত বুয়েটিয়ানরা বিজনেস সেক্টরে আছে, বিভিন্ন বড় সেক্টরে আছে, তাদের মধ্যে একটা কানেকশন তৈরি করা। তো ওখান থেকেও মানে মেইনলি ওইটাই আইডিয়া ছিল। বাট যে কোনো জায়গায় বিভিন্ন মানুষের, ওকে, জাস্ট টু গিভ ইউ অ্যান আইডিয়া, আমাদের ওয়ান অফ দ্য ক্লোজ ফ্রেন্ড, ধরো যে বিজনেসম্যান, তুমি ধরো একটা বড় অনুষ্ঠানে গেছো, তুমি যদি বিজনেস করার চিন্তা করো, তুমি খুঁজে বের করবে বড় অনুষ্ঠানে বিজনেসম্যান কারা আছে। তুমি যদি আহ আড্ডা দিতে পছন্দ করো, খুঁজে বের করবা কারা আড্ডা ভালো দেয়, রাইট? তো এটা মানুষের আসলে মেন্টালিটির উপর ডিপেন্ড করে। স্কোপ যখন যেখানে আসে, কখন কোথায় আসে বলা তো টাফ, রাইট? But let's do one thing. If you really want to know more, just send me an email separately, because I don't think other people, they're not everyone is interested about entrepreneurship, right? So let's talk about something everyone is interested about. Anyone else have any question? Any other question?
স্যার আমার দুইটা কোশ্চেন ছিল স্যার। স্যার প্রথম কোশ্চেনটা হচ্ছে এই বিমের ভিতর স্যার, মানে বিম
right?
জি স্যার।
Okay.
স্যার বিমে কি স্যার আমরা যেমন যে শুনছি যে স্ট্রাকচারাল অ্যানালাইসিস এর জন্য আমাদের বিভিন্ন স্ট্রাকচারস এর বা হচ্ছে ওই যে বিল্ডিং এর মেম্বারের ভিতর ফোর্স ক্যালকুলেশন করা লাগে, বিমও কি আমার জন্য এটা করে দিবে?
Exactly, this is a very good point. Thank you, Imtiaz. Beam, এখন যেগুলো beam auto, just give me 1 minute. I think Abir are just. Abir, Sanjay, just give me 5 more minutes, okay? Thank you. Sorry, Abir, Sanjay, they're already here for the next meeting. Anyway, হ্যাঁ, বিমে যেটা এখন করা যায় সেটা হচ্ছে অটোডেস্কের একটা পুরো প্যাকেজ নতুন বের হয়েছে, যেটাতে 3D মডেল, যেহেতু 3D মডেল করা হয়ে যাচ্ছে এবং 3D মডেলের সাথে সাথে আমি কিন্তু ম্যাটেরিয়ালও অ্যাসাইন করতেছি, যেটা আমার কনক্রিট কলাম, এটা আমার স্টিল কলাম, রাইট? তো ইউ হ্যাভ অল দ্য ইনফরমেশন, এবং বাকি যেগুলো ইনফরমেশন যেমন স্ট্রাকচারাল অ্যানালিসিসের জন্য দরকার, সেটা হচ্ছে যে কোনো বিল্ডিং এর সেলফ ওয়েট কিন্তু একটা বড় ইস্যু, তাই না? তো সেলফ ওয়েটটা অলরেডি ওখানে আছে, যেহেতু আমার সব ডিটেলস আছে। আমার খালি লাগবে হচ্ছে এখন উইন্ড লোড কোড বা এই কোড গুলো অ্যাড করতে হবে। তো এখন যেটা হচ্ছে যে অটোডেস্কের পুরো সিস্টেমের মধ্যে, পাইপলাইনের মধ্যে, once you have the precise 3D model, you can transfer it to the structural analysis. You can just do the structural analysis there, বিমের মধ্যেই। এবং শুধু তাই না, ইভেন যেটা আমরা বাংলাদেশে করি না আসলে, এইচভ্যাক যে সিস্টেমটা অ্যানালিসিস, যেটা আমাদের রেগুলার বিল্ডিং এ হয় না, বাট এনি ওয়েস্টার্ন কান্ট্রি গুলাতে সাধারণত সব বিল্ডিং সেন্ট্রালি এসি করা থাকে বা এইচভ্যাক সিস্টেম থাকে। তো ওই এইচভ্যাক সিস্টেমটা ওখানে ওই বিমের মধ্যে অ্যানালিসিস করে ফেলা যায়। Did I answer your question?
জি স্যার। স্যার স্যার এই সফটওয়্যারটা স্যার শেখাটা মানে কতটা কঠিন, মানে আমাদের এই লেভেলে কি আমাদের দ্বারা পসিবল এটা?
খুবই সোজা, খুবই সোজা, কোনো কঠিনই না, খুবই সোজা। কারণ হচ্ছে আমরা এখানে আন্ডারগ্রেডকে এগুলো শিখাই, এবং তারা অনেক ভালো করতেছে শিখে। জাস্ট কাউকে শেখাতে হবে, বা ইভেন কাউকে শিখাতেও হবে না। আই ডোন্ট নো যে বুয়েট থেকে, যেমন ম্যাক্সিমাম আমেরিকান ইউনিভার্সিটির যে আমাদের অ্যাকাউন্ট আছে, সেখান থেকে আমরা লিঙ্কডইন লার্নিং এ ইজিলি অ্যাক্সেস পাই। তোমাদের কি বুয়েটিয়ান ইয়ে আছে, কি বলে, ইমেল অ্যাড্রেস আছে, .edu ইমেল অ্যাড্রেস? তো ইমেল অ্যাড্রেস গুলো কি buet.edu এরকম কিছু আছে? ও আচ্ছা, আচ্ছা। .edu থাকলে যেমন এই এই যে সফটওয়্যার গুলো, অটোডেস্ক, রেভিট, এগুলো ফ্রি। তো তারপর লিঙ্কডইন লার্নিং এ আরে ভেরি গুড। তাহলে যদি ওইটা হয়, অটোক্যাডের লাইসেন্স তো তাহলে একটা অ্যাকাউন্টে আছে, রাইট? অ্যাকাউন্টে লগ ইন করলে তারপর ওখানে লাইসেন্সটা অ্যাড করা। তো ওখানে তোমরা যদি যাও, তার মানে তোমার অলরেডি একটা স্টুডেন্ট অ্যাকাউন্ট রেজিস্ট্রেশন করা আছে, রাইট? তো তোমরা যদি ওখানে যাও, গিয়ে ওখানে তোমরা রেভিট অ্যাড করতে পারবা, অটোডেস্ক রেভিট। রেভিট যদি লাইসেন্সটা অ্যাড করো, দেন ইউ ক্যান অলসো ইউজ রেভিট ফর ফ্রি। এবং মেইনলি আমরা রেভিটই ইউজ করি হচ্ছে এই 3D মডেলিং, বিম মডেলিং এগুলোর জন্য। ইউ ক্যান স্টার্ট ডুইং দ্যাট।
স্যার আই থিংক আমাদের এখনের যেই ইয়াটা আছে আমাদের, ওইটার মধ্যে অনলি একটা সফটওয়্যার অ্যাড করা যায়। আমরা অনলি একটা সফটওয়্যার অ্যাড করছি ফ্রিতে।
আচ্ছা,
এখন স্যার ওই রেভিটে অ্যাড করতে কি এটা কি এক্সট্রা একটা সফটওয়্যার না স্যার?
এক্সট্রা একটা সফটওয়্যার, কিন্তু এরকম কোনো নিয়ম নাই যে একটা করা যাবে। অ্যাজ লং অ্যাজ ইউ হ্যাভ এ স্টুডেন্ট অ্যাকাউন্ট উইথ অটোডেস্ক, ইউ ক্যান অ্যাড অ্যাজ মেনি অ্যাজ সফটওয়্যার।
ওকে স্যার।
যদি সেটা স্টুডেন্ট অ্যাকাউন্ট হিসেবে ওরা ভেরিফাই করে থাকে। অ্যান্ড এরপর শেখার যে ব্যাপারটা, যেটা ইমতিয়াজ জিজ্ঞেস করলো, চৌধুরী ইমতিয়াজ, তো সেটা হচ্ছে যে সাধারণত মানে একে তো আমরা ক্লাসে এগুলো শিখাই, হাতে ধরে শিখাই আমার ক্লাসে, বাট দেয়ার আর সাম রিয়েলি গুড লিঙ্কডইন লার্নিং training course, but they're generally paid. So for a student in US, they're free, but most likely বাংলাদেশের জন্য মনে হয় না লিঙ্কডইন লার্নিং ফ্রি, right? So, but you can always find these alternative YouTube courses, right? It's easy, and এবং one of the good thing, বাংলাদেশে কি এখনো বুয়েটে কি এখনো ওই যে হাতে স্কেচ করা শেখায় বোর্ডে, মানে বড় ড্রয়িং পেজের মধ্যে হাতে স্কেচ করে, সিভিল ড্রয়িং, রাইট।
Yes, sir.
So this is amazing, this is actually amazing. আমি এখানে আসার পর দেখছি যে এখানে স্টুডেন্টরা 4th ইয়ার 5th ইয়ার উঠে গেছে, বাট তারা সেকশন বা এই ভিজুয়ালাইজেশন গুলা তাদের নাই, কারণ তারা সারা জীবন সফটওয়্যার ইউজ করতে করতে ওই জিনিসগুলো আর বোঝে না। কিন্তু বুয়েটের স্টুডেন্টদের যেটা হয় যে যেহেতু আমরা সবাই ওই সিভিল ড্রয়িং করে অভ্যস্ত, তো উই ক্যান অ্যাকচুয়ালি আন্ডারস্ট্যান্ড হোয়াটস গোয়িং অন দেয়ার, রাইট? তো মানে তোমাদের জন্য অনেক ইজি হবে জিনিসটা শেখা। রেভিট ক্যালকুলেশন করা না, ওটা আরেকটা অটোডেস্ক স্ট্রাকচার সামথিং, তো ওটা আরেকটা সফটওয়্যার। পুরো পাইপলাইনটার জন্য আসলে লাইসেন্স লাগবে। হ্যাঁ, এটা এটা খুবই আনফরচুনেট। সরি, আরেকটা ইমতিয়াজ মনে হয় দুইটা জিজ্ঞেস করেছে, রাইট?
জি স্যার, জি স্যার, আর কিছু?
Okay. If you guys have any question, you can always reach out to me or my student. They are also তারাও তো বুয়েটের স্টুডেন্টই ছিল, তো I guess they'll be very open to questions. Or Dr. Aziz তো আছে, Dr. Islam, he can also help you connect with us. Okay, so
Yeah,
if
sure.
there's no
So
more
কারো যদি
question,
অ্যাডিশনাল কোনো কোশ্চেন থাকে তাহলে হচ্ছে যে হ্যাঁ, তাহলে আমাকে ফরওয়ার্ড করে দিলে আমি হচ্ছে ডক্টর সাকিবের সাথে কন্ট্যাক্ট করতে পারবো, অথবা কেউ যদি বেশি ইন্টারেস্টেড থাকে তাহলে সে নিজে ডক্টর সাকিবের সাথে কন্ট্যাক্ট করতে পারে। আর আশা করি অলরেডি অনেক বেজে গেছে, 10:50
হ্যাঁ,
আমাদের এখানে।
আমার স্টুডেন্ট
So,
অলরেডি ওয়েট করতেছে, we have a
আ-
meeting with them.
আশা করি আর হ্যাঁ হ্যাঁ আচ্ছা, আমরা তাহলে তাড়াতাড়ি এখন শেষ করে দিই। থ্যাংক ইউ সো মাচ ডক্টর সাকিব। আহ, আজকের লেকচারটা আসলেই অনেক ইন্টারেস্টিং ছিল। আপনার ইন্টারেস্টিং প্রজেক্টগুলো আসলে আমাদেরকে দেখাইছেন, প্লাস আপনার লাইফ এক্সপিরিয়েন্স গুলো শেয়ার করেছেন। সো ডেফিনেটলি আমরা হচ্ছে যে অনেক বেশি কিছু জানতে পেরেছি আর কি। সো আশা করি আমরা যারা কোনো স্টুডেন্টরা আছে তারা অবশ্যই অনেক উপকৃত হবে এই লেকচার দিয়ে আর কি।
না,
আচ্ছা।
ডেফিনেটলি ডক্টর ইসলাম, থ্যাংক ইউ ইনভাইট করার জন্য। মানে উপকৃত মেইনলি বলতে কি, I just wanted to show them that there is no limit. মানে আমার ছিল সিভিল ইঞ্জিনিয়ারিং ডিগ্রি, সেখান থেকে আমি কিন্তু এখন পুরো কম্পিউটার সায়েন্স ব্যাকগ্রাউন্ডে চলে আসছি। So if you really want to do something, there is no limit, and just you just have to try. That's it. Thank you everyone for your time. Really appreciate it today. Bye. Bye,
Alright.
Dr. Islam.
Thank you everyone. Thank you again, Dr. Sakib. Have a wonderful day.
Good
And
day, everyone.
good night, everyone.